Hi, my name is Dale Maley. In this short video, I'm going to show you how to use the MotionGen simulation program to design a pretty interesting marble escapement mechanism. A little background on myself: I like designing and building hand-cranked marble machines. A few days ago, I just did discover a free simulation program called MotionGen. If you do a Google search for MotionGen, you can find the program, and you don't download it, you actually run it on your web browser. Here's the internet address for that simulation program. With all software, there is a learning curve. It takes a while to learn how to use it. I like video examples to help me quickly learn how to use a new program. I decided to make this video to help people quickly learn how to use this software. And as I said before, we'll be designing a rather unique marble escapement mechanism. Now, this marble model or game is completed, and I made a YouTube video just covering the model. You can watch that if you're interested. But one key part of this model was, how can I load just one marble at a time into the bottom piston? And the piston's shown in blue. It moves up and down. And like I said, I need to release just one marble per stroke of the piston. Now, in this view from SketchUp, I took off the front part of the piston so you can see what's going on inside. There's an angled hole drilled in that piston. These are 1-inch marbles. So we want one marble to load into the piston, but not the next marble. So we want that orange arm to come down and keep the next marble in place until the piston goes up and comes back down, is ready to load. Now, I decided to use the bottom of the blue piston to actuate this mechanism. And we can vary it, but I kind of targeted a 1/4 inch of travel, the last 1/4 inch at the bottom. You can increase this if you want, but that's what I got. So since the marbles are 1 inch, we're going to need that orange arm to lift up a little bit more than 1 inch to clear the marbles. Now, several weeks ago, when I actually did the design work and figured out this loading mechanism, I did it all by trial and error in the SketchUp drafting program. In retrospect, it might have been easier to first use this MotionGen program to get the motions right and then draw it up in SketchUp. But since I have it done, we'll get the key dimensions from the SketchUp drawing, and we use those and put them into the MotionGen program. You could start out in the MotionGen program and try to generate it from scratch, and then take it into SketchUp, whichever way works for you. Now, don't worry about reading the numbers here, but I'm just showing you that I went into SketchUp, and then I measured and found the XY coordinates for all the key points in the linkage. Once I know those XY points, I can enter those into the simulation program. Now, there's probably a more efficient way than what I'm going to show you here on how to draw a representation of that swing arm, but this method works, and you'll probably figure out a faster and easier way, but at least it's one way to make it work. So let's just add a link off the menu to get started. But this has 3 points, 3 key points on that swinging arm. So let's add a joint from the menu, add joint, doesn't matter where. Okay, from SketchUp then, we know the tip of this, so we know the coordinates. And the coordinates for the tip are minus 1.25. And the y coordinate is 2.523. Okay, now for that center pivot point, we know the coordinates for that, and that should be 4.092. X and y is going to be 4.619. Then for the right hand fixed point over here, we know the coordinates for that should be 7.55x, and y should be 1.634. Okay, we'll scroll out a little bit so we can see it better. Okay, now there's another feature called draw arbitrary polygon. So we're going to try to draw a better representation of our swing arm. And once we get that done, we'll merge it in with this, and that'll be a better representation. So let's click on Draw Arbitrary Polygon. Let's try taking it up at an angle a little bit above that pivot point like that. We'll bring it on across. We'll come down over here. Now we need to be below that point, so it's included. Then we'll take it over here. And I'm going to bring it down a little bit below that point. And I'm going to connect it there. Okay. Now we're going to do multi-select. Pick the whole thing. Then down on the menu near the bottom, there's a merge command. So we're going to hit merge. And voila! We have something that looks closer to our swing arm on that side. So we can build the rest of the mechanism next. One thing I will point out though, if you try to move one of these points, you're probably not going to move the tip. But you may want to move this pivot point up here or the pivot point on the right. And if you attempt to do that, we'll show you, it screws up the shape of your arm. Okay? So we will return it back. Okay. But if you want to move that pivot point and see what happens, all you have to do is go in and add a joint. And let's say you want it here. And that particular joint, you can move that around and it doesn't mess up the shape of your arm. So watch, we'll move it up here and it has no impact on the arm. So that's a way to try out different geometry without messing up the shape. Yep, we got rid of it. Okay, we're ready to build the rest of the mechanism. So now we'll do the little link at the bottom, which is kind of a balancing beam type thing, or a cantilevered beam. Oops. I don't know why I drew multiple links there, but okay. Now this one also has 3 points on it, so we need to add a joint. So go over and pick Add Joint. We'll put it there. Okay, so on the left hand from SketchUp, we know that X is minus 2.166 and we want Y to be 0.409. The pivot point in the center, we want to start out and we make that 0, 0. So that's 0. Then on the right hand point, we know that needs to be 4.092 X, and Y is 0. There's that geometry. Okay, the only other element here, we need to link between the swinging arm and the little cantilever beam, so we'll add a joint. Okay, so the basic mechanism is drawn, but we need to anchor this one over here. So it's now grounded, as they called in this program. We're also going to need to ground this point over here. Okay, so now we just need a way to actuate it. So let's pick the point over here. So on the working model, we're going to have a piston that comes down and pushes this link down. So we're going to simulate that, we're going to add a linear actuator here, and we'll turn it around so it's this direction. Now we're going to go zoom in on that actuator, linear actuator. Try to get it around there. And if we click on the actuator, not the point, it should show us the stroke. And it's got a stroke of 0.135. Let's try putting in a stroke of 1/4 inch, 0.25. Didn't really change it. So what I found is if I just kind of trial and error, and I move it up a little bit, now we're at 0.145. Now we're 0.292. We're close to 1/4. Maybe bring it down just a hair. 0.29 yet. Oh, it's not changing. I don't know why. Okay, 0.27. That's close enough for right now. You can play around with it some more. Now notice as we scroll out here, we don't have the play button for simulation. So that means we haven't completed it. So what are we missing? Well, is that grounded? Yes. I'm not sure what we're missing. So let's take this on up just for the heck of it. We'll try it the other direction. Not sure why our simulation's not showing up here. That's grounded, which is what we want. That's not grounded. That one there is grounded. So it should, the simulation play should be showing. Not sure what's wrong at this point. Oh, wait a minute. I forgot to ground this end down here. Sorry. There's the blue lines and the simulation play is going to be up. So I forgot to ground that. So let's go back down here. And let's click on it again, see if we can get the stroke out of it. 0.309. We're just over our 1/4 inch desired stroke. We could go in and massage it just a little bit down, just a hair. 0.309, we're just a hair over. We'll move it down just a little bit more. 0.24, we're close to 0.25. Okay, let's zoom out so we can watch it run. Now, what's interesting is it shows the path of the moving elements in blue. So the key one over here, that point we want to go down in the marble, it's showing how far that's going. Now, each grid on here is 1 inch. So right now, just ballparking it or eyeballing it, it's moving about 1 inch. That's about what we want. The marble's 1 inch, so we're going to need it to go a little bit more than that, but we're close on the ballpark here. So let's run the simulation. Simulation's working. Run it again. And here we go. So we've completed this simulation. Now, in this case, if we want to play around with the stroke of the tip of the arm, how to change that, we can do that. For example, if we move the fulcrum point, let's see, as we move it to the left, that's probably going to increase the stroke. Yes, it does, dramatically. And if we move it to the right, it's going to decrease the stroke, which kind of makes sense just looking at the mechanism on that side. And as I said before, if you want to move this pivot point up here, you probably need to go add a joint and then move that around to what you want to try and leave this one alone. Because if you try to move this one, you're going to destroy the shape of the arm. Okay, not too bad. It'd be a pretty handy method to play around with this mechanism. And we know how much stroke we have over here, around 1/4 inch, and we know we want a little more than an inch and a half travel over here. So you can optimize the design, go back into SketchUp, and then modify the design. So some closing thoughts on this video. This MotionGen program is relatively easy to learn how to use, and the simulation software can be a very valuable tool compared to just using a drafting program only. So in summary, this video explains how to use the MotionGen simulation software to design a marble escapement. You can see my many other videos that has a lot of different marble machines and all the associated mechanisms that operate them. Hopefully this video helps you on your projects. I hope you enjoyed the video, and please subscribe. Thank you.